Okay, thank you everyone for joining the live stream today. As usual, you can send in your questions. If you have any questions as we walk through the problems that have been already selected, feel free to post them on the live chat and I will try my best to get through the questions. One of the things I've done for today's session is there were a few questions yesterday that were not part of the topics I had prepared to talk through or to work problems on. And so what I've done is find some questions on those topics and then use this as an opportunity to go over those topics. So what I'm going to do today is I'm going to walk through about 11 problems. They're ranging from about grade 3 math all the way to about algebra 2. And let's get started. The first question we have here is to express 24 divided by 64 in its simplest form. So I have 24 divided by 64. So what we're going to do here is we want to keep reducing this fraction until we get to the simplest form that can no longer be reduced. So here we have 24 divided by 64. Because they are even numbers, we can divide them by 2. Divide these numbers by 2, and now we are left with 12 divided by 32. Now these are even numbers as well, so we can divide this by 2. And now we are left with 6 divided by 16. We still have even numbers here. We divide by 2. And now we are left with 3 over 8. So what we're saying here is 24 over 64 and 3 over 8 are what we call equivalent fractions. Let's look at the next example. Multiply 158 by 23 using the matrix method and the algorithm method. So I'm going to use the matrix. To use the matrix, let's write here, this is the matrix method. To use the matrix method, I have to decompose 158 and 23. So 158 is the same as 100, that's the place value of 1, plus 50 plus 8. And then 23 is the same as 20 plus 3. So now let's go ahead and decompose. So I have 100, 50, and 8. And then I have 20 and 3. So let's draw some. It's going to be a rectangle. So let's go ahead and create our matrix. So 20 multiplied by 100. So because we have all zeros, 2 multiplied by 1 is 2. And then we have 3 zeros. 20 multiplied by 50. Let's start with 2 multiplied by 5. We have 10. And then we add 2 zeros to the end. 20 multiplied by 8. Let's focus on 2 multiplied by 8. We have 16. And we have a 0 at the end. And then 3 multiplied by 100. We have 300. 3 multiplied by 50, we have 3 multiplied by 5, that's 15. We end with a 0. And then 3 multiplied by 8, we have 24. So now let's go ahead and add all of these columns together. So this is going to give us, let me use a different color just so we can see that. This is going to give us 4 right here. Let me write correctly. So 0 plus 4 is going to give us 4. 6 plus 2 is going to give us 8. 1 plus 0 is going to give us 1. And then I'm going to write 150 so it's aligned with 1,000 just to make it easier to read. So this is 150. So now I have 0 plus 0 is 0. 0 plus 5 is 5. 0 plus 1 is 1. And then 1 plus 0, there's nothing here, so it's 1. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 3 is 3. 2 plus 0 is 2. So now to use the matrix method, we're going to add all of these numbers together. So we have 2,300, 1,150, and then 184. We're going to replace 0 with the column that is missing there. So 0 plus 4, that's going to give us 4. 0 plus 5, that's 5, plus 8, we have 13. We're going to write 3 and bring 1 up here. 1 plus 3 is 4. 4 plus 1, 5. 5 plus 1, 6. 2 plus 1, 3 plus 0, that is 3. So this is the matrix method. This is very common in about in the third grade and maybe early part of fourth grade, when students are learning to multiply numbers that are 2 digits or more. Now let's use the algorithm method, and this will most likely be used for students toward the end of fourth grade and in fifth grade as well. So let's look at 158 multiplied by 23. 158 multiplied by 23. So we'll always start from the ones position. 8 multiplied by 3, that should give you 24. So we're going to write a 4 and carry up a 2. 5 multiplied by 3, we have 15. Plus 2, we have 17. So we write 7 and we bring 1 up here. 1 multiplied by 3, it's 3. Plus 1, we have 4. Now, we finished with the ones place. Now we're going over to the tens place. Remember that any number that is in the tens place, if you write that number if you write it out, like we have 50 here and 20, it always ends with a 0. That's the reason why we put a 0 here, because if you multiply anything by a number in the tens place, you have a 0 at the end. So 8 multiplied by 2, 16. So we start our numbers in the tens place. 8 multiplied by 2 is 16. We write 6 and we bring 1 up here. 5 multiplied by 2, that is 10. Plus 1, we have 11. We write 1 and we bring 1 up here. 1 multiplied by 2, we have 2. Plus 1, we have 3. So we replace this with a 0 here because there's no number in that column, and then we add all the numbers together. So let's go ahead and add the numbers together. 4 plus 0, we have 4. 7 plus 6, we have 13. So we write 3 and we bring 1 up here. 1 plus 4, 5 plus 1, 6. And 0 plus 3, we have 3. So you can see that regardless of the approach you take, you will get to the same answer. Also, if you want to see more examples of how this can be done, we have videos covering this on our YouTube channel. And feel free to ask questions as we go along. I'll be glad to help you with those questions as well. Now we have some decimals. We're going to be adding some decimals here. So we have 12.345 plus 9.05 plus 158.6. Now we're going to write the first number. Let's go ahead and write the first number. It's 12.345. And then the second number, you notice that it's 9.05. So what I like to do is I tell my students to make sure that all the decimals are lined up. So I'm going to put a decimal point right here. And then the number to the left of the decimal is 9. The number to the right, you have 0, 5. And then after the number you have, you can replace it with a 0. So you have the same number of digits after the decimal. Now for the third number, let's put a decimal point right there. After that, we have a 6. So this is going to be, put a 2 zeros at the end because we have only one number after the decimal. Now look at, we have 3 digits before the decimal. So let's use our place value to work this out. So we have 8 is in the ones position, 5 is in the tens position, and 1 is in the hundreds position. So what we're going to do now is we're going to replace all the positions here that don't have values with 0, just so we have the same number of digits for all the three numbers. Now we can add this together. 5 plus 0, 5 plus 0, that is 5. 4 plus 5, 9 plus 0, we have 9. 3 plus 0, 3 plus 6, we have 9. And then we have our decimal right here. 2 plus 9, we have 11. Plus 8, we have 19. So we have a 9 and we bring a 1 up here. 1 plus 1, 2. Plus 0, 2. Plus 5, 7. And then 0 plus 0 plus 1 is 1. So you can see that when we take this approach, you have the right number of digits for your solution. Students often make a mistake of ignoring this approach and they end up with answers that are very inaccurate. So take note of this. Like I said, for every topic I'm going to walk through today, I have videos already created that should help you out. The next question, this was a big question yesterday, so I wanted to solve a few problems on this to help students get more comfortable with it. So we want to express this in scientific notation. Some will call it standard notation. So what we're going to do here is the first thing you want to do is to write this number. Forget about the decimals or any commas, 74920. Now what I'm going to do is to make sure I place the decimal I have to make sure that there's only one number to the left of the decimal. So I'm going to place the decimal right here. I'm going to place the decimal right there. So there's only one number to the left of the decimal. Now I'm going to go back to the original number and I'm going to ask myself, what do I need to do? How many places do I need to move my decimal from where I think it should be to where it is right now? This is where it is right now. When you have a whole number, the decimal is right after the number. So what I'm going to do is, this is where I think it should be, and then I'm going to go 1, 2, 3, 4. So I'm going 4 hops from where I think it should be to where the decimal is currently. And then in what direction did I go? I went towards the right. Remember, when you have a number line, you have 0 in the middle, the numbers to the right. If you go towards the right, you have positive numbers. If you go toward the left, you have negative numbers. So it's going to be, I made 1, 2, 3, 4 hops. So it's in the right direction. So it's going to be to power of a positive 4. Let's look at another example. We have 0. Let's do 0, 0, 9, 4, 5. So I want to make sure that there's only one non-zero digit. So that is just one digit. It's a number that is not 0. So the only number that is not 0 here is 9. So I'm going to put a decimal right here. And so what I'm saying here is that 9.45, the decimal should be right here. This is where I think it should be. But this is where it is currently. So I'm going to see, how do I get there? I have to go 1, 2, 3. But I'm going in the left direction. Because I'm going in the left direction, I'm going to have a negative value. So this will not be a good way of writing this. So instead, what you want to do is 9.45 times 10 to the power of negative 3. So now I have this number, 7,907,000. Like I said earlier, our decimal is going to be after the whole number. But I want to make sure that the decimal is between two non-zero numbers. So I have 7.907000. So right now I'm saying that the decimal should be here, right here, but it is right here. So let's see how many hops I need to make to get from where it should be to where it is. So I have 1, 2, 3, 4, 5, 6. And in what direction am I going? I'm going in the right direction. So this is going to give me 7.907 multiplied by 10 to the power of 6, because I am moving 6 units to the right. Now let's look at going from standard notation to an ordinary number. So what that means is I'm going to write this as a decimal or a whole number. So let's look at this 6.92. We have 6.92, and we're saying that we want it multiplied by 10 to the power of -4. So it means that we're going to move in the negative direction. So we're going towards the left. So let's see, this is 1, 2, 3, 4. So this is where our decimal should be. Our decimal is going to end up here. So for every loop you create, we're going to replace that with a 0. Let me show you what that means. I'm going to put a 0 right here, a 0 right here, a 0 right here. And before the decimal, I'm going to place a 0. Remember what I said yesterday, that when you have a negative exponent, which is this number right here, the number you're going to get will be less than 1. So this is going to give me 0.000692. Let's look at the second example. 3.804 times 10 to the power of 5. 3.804. We want to go 10 to the power of 5. So this is a positive 5. So that means we're going to move in that direction. So this is going to give us, we go 1, 2, 3, 4, 5. And this is where our decimal goes. So like we did earlier, every place there's a loop, you're going to replace with a 0. So this is going to give you 3.80400. And then we count 3 to the left, from the right to the left, 1, 2, 3, put a comma. Next example we have is 3.45 times 10 to the power of -2. 3.45. We have -2, so that means we're going to go 2 units to the left. So we go 1, 2. So everywhere you have a loop that is empty, you're going to replace it with a 0, and then you're going to have a 0 before the decimal. So this is going to give you 0.0345. I hope this clarifies the questions that came through yesterday about standard notation. If you have any more questions, you can post them here, or you can also check our videos that focus exclusively on this topic. Now we're going to convert 7/25 to a decimal. Remember, when you have 7/25, your numerator goes in the division, and then your denominator is actually your divisor. So 7 divided by 25, because 7 is less than 25, you know that you're actually going to get 0. You put a decimal, that gives you the permission to add a 0 here. So 70 divided by 25. How many groups of 25 can you find in 70? Let's try 25 multiplied by 3. 5 times 3 is 15. Bring 1 up here. 2 multiplied by 3 is 6 plus 1, 7. So it's 75. So we're going to have 2 right here. 2 multiplied by 25 is going to give you 50. And then we subtract here. We have 20. And then we have a permission. Because of this decimal, we have the permission to keep adding zeros until we can no longer go ahead. So we have 200. 200 divided by 25. I'm going to try 8. 25 multiplied by 8. 5 multiplied by 8 is 40. So I write 0 here, and you carry 4 up here. 2 multiplied by 8 is 16 plus 4. That's 20. So it's going to give me 8. 8 multiplied by 25 is 200. And when we subtract, we have 0 as our remainder. So therefore, 7/25 is the same as 0.28. Now this was a question from yesterday as well. For triangular prisms, we want to find the lateral surface area. So let me reiterate what I said yesterday about lateral surface area. So for lateral surface area, we have perimeter of base multiplied by the height. And for total surface area, I have lateral surface area plus 2 multiplied by the area of the base. And then for volume, we have area of the base multiplied by height, which is equal to B multiplied by H. So now let's go ahead and start with lateral surface area. Lateral surface area, we have perimeter of the base. So we can assume here, so lateral surface area, perimeter of the base. I'm going to make an assumption here that this is an equilateral triangle. So our base right here is an equilateral triangle. So that's going to be 10 plus 10 plus 10. And then we multiply by the height of the prism, which is 12. So this is going to give us 30 multiplied by 12, which is going to be 360. And then total surface area is lateral surface area plus twice the area of the base, which is 1/2. The base is 10, the height is 7. So this is going to be 360 plus, we can divide 2 here by this 2, so plus 10 multiplied by 7, which is going to be 360 plus 70, which is 430. Now the volume of these is going to be the area of the base multiplied by the height. What is the area of the base? From this total surface area question, the area of our base is 70 here, and then our height is 12. This is going to give us 840. So now let's go ahead and place the units. This is square feet, and this is cubic feet. Now for a cylinder, we want to find the lateral surface area, total surface area, and volume. So lateral surface area is the perimeter of the base multiplied by the height of the cylinder. The total surface area is going to be the lateral surface area plus twice the area of the base. And our volume is area of the base multiplied by the height of the cylinder. So let's go ahead and start with the lateral surface area. Lateral surface area, the perimeter of the base is 2 pi r, and then our height is 20. And here, always remember that 2 pi r is the same as pi multiplied by diameter. So we have a diameter of 16, so this is going to give us 16 pi multiplied by 20. This is going to give us 320 pi centimeters, square centimeters. And then we have total surface area is going to give us lateral surface area plus twice the area of the base. The base is a circle, so we have pi r squared. So our lateral surface area is going to give us 320 pi plus 2 pi. What's our radius? Our radius is going to be pi multiplied by 16 over 2 squared. Okay, so let me actually write that properly. Pi multiplied by 16 over 2 squared. So that's going to be what we have here. So this is 320 pi plus 2 multiplied by pi times 8 squared, which is 320 pi plus 2 multiplied by 64 pi, and this is going to give us 320. Let me write that here. 320 pi plus 128 pi. So we're going to add 128. So that's going to give us 8 here, 4, 4. So this is going to give us 448 pi square centimeters. And then finally, we want to find the volume. The volume is area of the base, which is pi r squared multiplied by height. What is our area of the base right here? We have it as 64 pi, and then our height is 20. So let's go ahead and multiply 64 by 2. That should give you 128, and you append a 0 to it, and this is going to be your volume of the cylinder. The next question we're going to be looking at here is for Algebra 1 and Algebra 2 students. We're going to be multiplying binomials. And to do that, we're going to apply the FOIL method. FOIL, which is the first numbers. We multiply the first terms together. So that is 2x multiplied by 3x. We multiply the numbers that are on the outside. And so that's going to be plus 2x multiplied by negative 7. Then we multiply the numbers that are inner, so they are close to each other, plus 3 multiplied by 3x. And then we multiply the numbers that are the last number for each of the binomials, so that is 3 and negative 7. So this is plus 3 multiplied by negative 7. So now we have 2x multiplied by 3x, we have 6x squared. 2x multiplied by negative 7, we have minus 14x. 3 multiplied by 3x, we have positive 9x. 3 multiplied by negative 7, we have minus 21. So now we're going to simplify. 6x squared minus 14x plus 9x is minus 5x, and then minus 21. So that is how you would simplify this binomial multiplication. Simplify 3 multiplied by x minus 5 plus 2 multiplied by 3x minus 7y minus 4 multiplied by y plus 5. So we're going to distribute the numbers to the left of the parentheses into the numbers inside of the parentheses. So now I have 3 multiplied by x gives me 3x. 3 multiplied by negative 5 gives me negative 15. 2 multiplied by 3x gives me positive 6x. 2 multiplied by negative 7y gives me negative 14y. Minus 4 multiplied by y is minus 4y. Minus 4 multiplied by 5 is minus 20 or negative 20. So now we're going to group common terms together. So we have 3x plus 6x minus 14y minus 4y minus 20 minus 15. So you see we have all the common terms together, and I always like to put the variables first and then the numbers at the end. So 3x plus 6x, that's going to give you 9x. Minus 14y minus 4y will give you minus 18y. Minus 20 minus 15 will give you minus 35. So this is your simplified version of that expression. And then now we have a question for 5th to 7th graders. So Marianne earns $900. She spends $247 on rent and $48 on groceries. Her boss gives her a $75 bonus, and she gives $35 to charity. How much money does she have left? The way I would like to do this is I'm going to draw a table. I'm going to put a plus right here, and I'm going to put a minus right here. A plus, it represents the money she receives, a minus represents the money she spends. So how much does she receive? She receives 900 as her income, and she also gets a $75 bonus. Now, she spends $247 on rent, she spends $48 on groceries, and she gives $35 to charity. So that's a spend for her. So what we're going to do now is we're going to add all the numbers in the plus column and all the numbers in the minus column. Let's go ahead and do that. So let's add all these numbers together. 7 plus 8, we have 15 plus 5, we have 20 there. So I'm going to write a 0 and bring up a 2. 2 plus 4, we have 6 plus 4, 10, plus 3, 13. I'm going to write 3 here and bring 1 up here. 1 plus 2 is 3. Now let's go ahead and add this right here as well. 0 plus 5 is 5. 0 plus 7 is 7. And then 9 plus 0 is 9. So always remember you can always do this so that you have the same number of digits on every row. So what we have in this case is that she has received $975 and spent $330. So how much will she have left? It would be how much she has. So let's look at this. Amount left is how much she has, amount she has received minus amount she spent. So that what that means to us is 975 minus 330. 5 minus 0, we have 5. 7 minus 3, we have 4. 9 minus 3, we have 6. So after all her expenses, she has $645 left over. These are the questions that were selected for this session. If you have any additional questions, feel free to ask. We have some time. I will be able to help you address those questions. Let's give it some time. It could be any question on what we've covered so far, or if you want me to go back and clarify something that maybe didn't make sense as I was walking through it, I will be glad to do that. Or if you want new questions that, okay, binomials. Okay, let's go back to binomials. I'm actually going to write a new question on binomials so that we have something new to work with. So with binomials, we're going to look at multiplying binomials. So let's look at x plus 5 and then x minus 3. So in the United States, the method they use is FOIL. So what that means is that for each of the binomials, you're going to look at the first terms of each binomial. This is the first term. Then this outer means the binomials on the ends of, so if you look at this right here, this is on the end here, this is on the end here. So these are called the outer terms. And the I represents the inner terms. So when you look at the binomials, which of the terms are closest to each other? So those are your inner terms. And L represents the last term of each binomial. So let's do this. I'm going to try to do each of those groups of binomials in different colors just so you can see them. So let's look at the first terms. The first terms are x and x. That's this x right here and this x. And then the outer terms are x here and -3. So plus x and -3. Our inner terms are going to be 5 and x. So plus 5 plus x. And then our last terms are going to be 5 and -3. Plus 5 multiplied by -3. Now what we're going to do with this is we're going to we're going to simplify this. So x multiplied by x is going to give you x squared. X multiplied by negative 3 is going to give you negative 3x. X multiplied by 5 is positive 5x. And then 5 multiplied by negative 3 is negative 15. So now we're going to simplify this expression. So x squared, we don't have any other term that is common. So x squared, negative 3x plus 5x. If you want me to go through how to manage positive and negative numbers, I can do that as a different topic. But generally, when you have a negative and a positive, when the signs are opposite, you always want to subtract the numbers. So 5 minus 3 is going to give us 2x. But then the 2x here is going to inherit the sign on the larger number. The larger number here is 5, so it's going to inherit the plus sign. And then we have negative 15 at the end. So this is how you go about multiplying binomials. Then we look at decimals. Let's see. Let's go ahead and do some decimals. Let me try to add and subtract some decimals. Let's see, maybe that would help here. So let's go and I'm going to pick a few decimals. Let's see. Let's add here, and then here we're going to do some subtraction. Okay, so here I have 24.308 plus 6.15 plus 149.673. Okay, so what we're going to start off with is, we'll start off with the first number. So we have 24.308. And then we want to line up the decimals. So I'm going to put a decimal right here. And for 6.15, I have 6 right here, and I have 1, 5. There is an additional space, so I'm going to replace it with a 0. And then 149.673, I'm going to line up my decimal again. I have 673 after the decimal, and then 149. Let's put a 9 right here because it's in ones place. We have a 4 right here in the tens place and a 1 in the hundredths place. Best practice I recommend is to put a 0 in every missing spot so that you have the same number of digits for all the decimals you're working with. Now let's go ahead and add these numbers together. 8 plus 0 is 8 plus 3. We have 11. So we write 1. We bring 1 up here. 1 plus 0, 1 plus 5, 6. 6 plus 7, 13. I have a 3 here, and I bring a 1 up here. 1 plus 3, 4. Plus 1, 5. Plus 6, 11. I put a 1 here, and I bring a 1 up here. 1 plus 4, 5. Plus 6, 11. Plus 9, 20. So let's not forget our decimal here. So 20 is a 0. We bring a 2 up here. 2 plus 2 is 4, plus 0, 4, plus 4, we have 8, and then 0 plus 0 plus 1 is 1. So let's try another example with subtraction. Let's do some subtraction. Let's see, we're going to try 128.67 minus 49.836. Okay, let's do that. So 128.67, and then we're subtracting 49.836. So let's line up our decimals again. 836, and then we have 9 here, 4, and then we're going to put a 0 over here. So because we don't have a number to the right here, I'm going to replace it with a 0. And now we go ahead and perform our subtraction. So 0 minus 6, cannot do that. So I'm going to borrow 1 from here, go over to this neighbor, take 1 from 7. We're left with 6. But the one we take over here, we add it to 0. It actually comes as 10. So we add it to 0, it becomes 10. 10 minus 6, we have 4. 6 minus 3, we have 3. 6 minus 8, we can't do that. So what we're going to do is come over here and borrow 1. So we're left with 7 here. And the 1 we borrow becomes 10. So we add 10 to 6, it becomes 16. 16 minus 8, we have 8 right here. Now we have 7 minus 9. We can't do that, so we have to come over here and borrow 1. This column is left with 1. The 1 we borrow becomes 10. We add 10 to 7, it becomes 17. So now we have 17 minus 9, we have 8. 1 minus 4, we can do that. So we have to come over to our neighbor right here and borrow the only one he has, generous neighbor. We're left with 0. And the one we borrow becomes 10. We added 2 1 here, it makes it 11. 11 minus 4, we have 7. 0 is left here, 0 minus 0, we have 0. And that is the solution to this problem. Let's see if there are any more questions. Mean absolute deviation. Let's do that tomorrow. The mean absolute deviation, we can do that one tomorrow. So I will come up with some questions that we can use to walk through those. That takes more preparation. Could you do quadratic equations in standard, vertex, and factored forms? Let's try one example there, and I will be able to do some more examples of that tomorrow. So let me get a new page. Okay. So we're saying we want to get a quadratic equation in standard form, in vertex form, and in factored forms. All right. So let me come up with a function. F of x is equal to x squared minus 8x, let's see, minus 12. Let's try that. Okay, so ideally this is your standard form. Ax squared plus bx plus c. That's standard form. Now we want to write this in vertex form. This requires completing the square. So what we're going to do here is, let's go ahead and go through completing the square. So we have x squared minus 8x minus 12. So what you're going to do is you're going to focus on this right here. We're going to focus on this right here and try to make that a perfect square. So there are different approaches to do this, but the approach I find it to be more reliable, is to go this way. Let's start with a general thing that you should know. A perfect square, a plus b squared is equal to a squared plus 2ab plus b squared, and a minus b squared is equal to a squared minus 2ab plus b squared. So this is what you call a perfect square. So our goal here is to find a way to write this x squared minus 2x so it looks like a perfect square. Now, how would we go about it? We will, if you notice here, you have minus 2ab minus right here. So what we're going to do here is we have x squared minus 8x. We're going to add a value to make it a perfect square. We're going to add that value here. It's going to be minus 8 divided by 2 squared. Okay, so that's the value we're going to add. But because we want to keep the equation consistent, here's what you have to remember. Whatever you add to the equation, you have to remove it so that it ends up becoming a net 0. So this is minus 12 minus negative 8 over 2 squared. So this is going to now lead us to x squared minus 8x plus negative 4 squared minus 12 minus negative 4 squared. So this right here becomes our perfect square. This right here is our perfect square. So this ends up becoming x minus 4 squared, then minus 12 minus, what's negative 4 squared is 16. So now we can write this as x minus 4 squared minus 28. So let's see what else, and factored forms, we'll get into that. So the question you may ask yourself is, how do I know that this is actually correct? Now, when you have this, remember your vertex form is a x minus h squared plus k. That is your vertex form. So that means here a is 1, and then your h is negative 4. So your vertex is going to be 4 and negative 28. So that's going to be the vertex. So this graph is going to look something like this. Let's see, negative 12 x squared. So negative 12 is our y-intercept. Negative 12 is our y-intercept, so it's going to be right about here. Let's see if we have an x-intercept. Our x-intercept is going to be, let's go ahead and let me show you how to use this vertex to draw the graph if we want to test it. So the x-intercept of your vertex is going to be x equal to negative b over 2a, and then your y-intercept is f of negative b over 2a. So let's put this to work. So x right here, negative b, you have to remember that here a is equal to 1, b equal to negative 8, and c equal to negative 12. So negative b is going to be negative 8 over 2a. 2 multiplied by 1 is 2. This is 8 divided by 2, which is equal to 4. And then your y-intercept, your y value of the vertex is going to be f of 4. So now we're going to have 4 squared minus 8 times 4 minus 12. So we have 4 squared is going to give us 16 minus 32 minus 12. So 16 minus 32 is negative 16, then minus 12. This is going to give you negative 28. So your vertex is going to be, you can see here that I've shown you that it's 4, negative 28. This is one way to test if your vertex form is actually accurate, because you should be able to derive it using this method here. This method here should help you derive your vertex as well. Now, for this graph, our y-intercept here is negative 12, but our vertex is going to be 4 and negative 28. So let's just make an assumption that that's right here. So our graph is going to look something like that. So that's what your graph looks like. Now this, I can tell, it's not going to be a simple one to convert to let's say factored form. Can I explain how I got the vertex form? Okay, let me see. Let me try another example. I can do another example actually that goes through this in more detail. Let's do this. So we have x squared minus 4x, let's see, minus 32. Okay, let's do this one. So vertex, when you're writing in vertex form, you are actually completing the square of the quadratic. First thing you want to do is come over here and try to make this a perfect square. I showed you earlier that a minus b squared is a squared minus 2ab plus b squared. So what I'm going to do now is to find a way of writing this part of the equation here, of the expression, as a perfect square. So this is going to give me x squared minus 4x plus, we're going to add negative 4 over 2 squared to make it a perfect square. And then now we have minus 32. We have to subtract that again. Negative 4 over 2 squared. The idea behind that is, if you look at this, plus this and minus this ends up becoming 0. So it doesn't look like we changed the equation at all. So this is now going to give you x. Let me actually take this out. So we have x squared minus 4x plus negative 2 squared minus 32 minus negative 2 squared. So now our expression, because we want to write it as a binomial squared, so this is going to give us x, and we're just going to take the value from here, minus 2, and then squared, minus 32, minus 4. So this is going to give us x minus 2 squared minus 36. Now when we're trying to come up with the vertex from this, the vertex here is actually going to be the value here. If there's a negative right here, then you leave it as your vertex is going to be positive. If it's a positive number here, your vertex, the x value of your vertex will be negative, and then we have negative 36. So there are I have a video that goes through in detail how to do completing the square, several examples there as well. So this is what we're going to get for our vertex. Now, how do we prove it? There is a rule in algebra that for your vertex, the x coordinate is going to be minus b over 2a, and your y coordinate of that is going to be plugging in the value of your x coordinate back into the equation to get you your y coordinate. So your x here is going to be, remember that in this equation here, we always compare against ax squared plus bx plus c. So here, a is equal to 1, b is equal to negative 4, and c equal to negative 32. So we want to find out minus b over 2a. So this is minus negative 4 over 2 times 1. So this is going to give us 4 over 2, which is going to give us 2. So we can see right here, we verify that this value is correct. And then for the y value is going to be f of 2. We're going to plug 2 back into the equation. So this is going to give me 2 squared minus 4 times 2 minus 32. So this is going to give me 2 squared is 4. Negative 4 multiplied by 2 is negative 8, then minus 32. So this is going to give you negative 4 minus 32, which is negative 36. So you can see now that we verified that our vertex is actually correct from this process. Now, if you want to find out the factors of this, we're going to multiply a and c together. We get negative 32. And we want to find out what factors of negative 32 would give you a sum of negative 4. So let's go ahead and look at this. We have 1 and 32. So it's going to be negative, positive, or positive, negative. There's no relationship to 4 here. 2 and 16. You can have negative, positive, or positive, negative. And then the next one we have is 4 and 8. So we have positive, negative, negative, positive. The question here is, because our sum has to be a negative number, you can see here that 4 and 8 can give you 32 and can give you a sum that is related to 4. So because our sum has to be negative, I'm going to pick up the negative on the larger number and the positive on the smaller number. So therefore, what we're going to have for this expression is x minus 8 multiplied by x plus 4. And then if we want to go ahead and try to draw the graph, if we want to draw this graph, so I'm going to do this right here. So we have negative 8. So what we're going to do here is x minus 8 equal to 0. So x is equal to 8. Then x plus 4 equal to 0. So x is equal to negative 4. So we have negative 4 over here, we have 8 over here, and now we need to focus on our vertex. Our vertex is 2 and negative 36. I'm just going to make an assumption that is right here. And then what is our y-intercept? Our y-intercept is going to be this number right here. So our y-intercept is negative 32. It's going to be a big graph, I think. Okay, so let's make an assumption. Let's make some assumptions here that this is negative 32 and this is negative 36. So our graph is going to go from here. It's going to go from here, passes through this line right here, comes here, and then takes a curve, a bend, and come right here. So this is what our graph is going to look like. So this should take care of all the questions. So I see it's about how to write equations in standard form. I've shown you that. Vertex form and factored forms. So the only thing that is missing here is to just let you see that x squared minus 4x minus 32 is the same as x minus 8 multiplied by x plus 4. So that's all that's missing, and I think this should cover all the topics that have been asked. I'll look through again, and I know we're almost out of time. I'll look through again and come up with some other questions that we can try for tomorrow's session. I see here that we want something, how to multiply binomials. I'll do another example tomorrow. Let me just go through the different questions. Okay, mean absolute deviation for tomorrow. Okay, I hope this covers everything that everyone needs. If you have more questions, feel free to, you can actually post it as a comment on this video when it gets posted. I think you should be able to write comments on the video right now as it's streaming. Feel free to do that, or you can send an email, to us, info@mathis.com, or send a direct message on Twitter @mathistutors, and then we'll be able to get all these questions answered for you tomorrow. Does anyone have any other questions before we call it a day and plan to meet tomorrow at 1? Okay, thank you everyone. Thanks for coming to this this session, and I look forward to seeing you all again tomorrow. Have a wonderful day. Don't forget to subscribe to the channel so that when the video gets posted, you get a notification, and also can share with your friends. I'm sure there are a lot of students out there right now that may not have access to someone who can answer questions for them. Please share with your friends as well, so that we can have a nice community going over here. Thank you very much. Have a blessed day.